Here is something else to scare you further about allocating and deallocating heap memory. As you go ahead and create your program and create classes and functions and methods, in some situations, especially in situations which were not designed very well, you may accidentally delete the pointer as you should, which means that right now you're freeing up the memory that was allocated when you created the variable. But then, without paying attention, you might delete that same pointer again for whatever reason. Let's say, for example, you made some sort of if statement that if blah blah blah, then delete the pointer. And then if something else, then delete the pointer. And then somehow both conditions were true, so you will be deleting the pointer once in the first if statement and then again in the second if statement because both conditions were somehow true. The consequence of doing such a thing is once again undefined behavior, which I won't go into detail again anymore. To make it short, from this point forward your program is totally screwed up, and if you're lucky, your compiler or operating system will stop you in your tracks and crash the program or something, and if you're not lucky, you may even just crash your computer or something. So here's the solution which you should never forget about. As soon as you've deleted a pointer, set the pointer to null. Assign 0 to the pointer and make the pointer null. From this point forward, if you ever try to delete the pointer again, you are safe and nothing bad will happen. So again, for your own security, every time you delete a pointer, assign that pointer 0. Make it null. Let's go over the rules. If you decide that you need some variable or something which must survive through different levels of scope, then you can create that variable or something on the heap memory using the new keyword. Once you did that, you will get an address in that memory, and you should assign that address to a pointer. It is only with pointers that you can possibly access this variable from this point forward. And from that point forward, you can go ahead and start dereferencing the pointer and using the variable. And then you can go ahead and pass the address of this variable, meaning the pointer itself, into different levels of scope, different functions, whatever you'd like, and use this variable for exactly as long as you need it. As soon as you're done with this variable and you don't need it anymore, do yourself a favor and don't forget to deallocate, delete the memory that you allocated with the new operator using the delete keyword, followed by the pointer which points to that memory location. Once you did that, any pointers which happen to be pointing to this same memory location, whether it's just one pointer or a couple of other pointers, make sure that they are immediately all set to null by assigning them 0. Every new must have a matching delete, and every delete must be followed by the pointer being set to null. If you follow these rules, you may possibly have a chance of surviving using the heap memory. Otherwise, you're in bad shape, and your program can easily be completely messed up from that point forward where you made a mistake. This is one of those things that people talk about when they say that, yes, C++ is a very powerful and strong programming language, but it's actually so powerful and strong that you got too much power, and if you don't know what you're doing, you can mess things up very, very badly. And they're right. It is way too easy to accidentally create a variable on the heap and forget to delete it, or to delete it and then delete it again, or to delete the variable but then continue to use the pointer as if it was not deleted, or many other different ways of screwing up. So you better learn the rules very well and review them again and again, getting into good habits of deleting everything that you create, etc., 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 all the rules that I just mentioned. Actually, you know what? Guess what? I happen to like C++ programming very much, and I do that all the time. And in fact, if I think about it now, it's been a good couple of months now that I have not used new or delete, not even once. Yep, that's right. Turns out you can survive pretty well without using new and delete, not even once. And here's the reason why. Basically, throughout all of your programs that you'll probably make, you will have two different types of variables that you'll be creating. The first type I like to call singles. Basically a whole bunch of little small variables here and there, maybe even a couple of objects of custom classes that you created here and there. Nothing major, a couple of integers over here, a couple of objects over there, maybe even a lot of them, but nothing really very serious and big. And for all of these little single variables and objects you create here and there, you should have no problem surviving with just creating them the regular normal way and letting the program handle all the details about the variable's address and all that, and you just give your variable a name and be done with it. Of course, if you'd like, you can pass the address of this variable into some other function, and using pointers you can manipulate it, as I spoke of in a different video. The other types of variables that you will be creating is what I personally like to call masses of variables. Like at some point in your program you might need to create something like maybe 100,000 integers. Or let's say you created your own custom class, let's say that it's something like a soldier character in a game, and you will be making a whole army of these soldiers, so you will probably need to have something like 1,000 of these soldiers, or maybe even just 100 of these soldiers, when inside each one of these instances of soldiers there can be several hundreds or even less of small little variables or smaller classes. In this case, when you will be creating masses of variables, you will most probably be using what we will learn about later on, something called containers. Containers is something like an array that we learned about in a different video, where you create a whole big package of variables that's going to be stuffed all together in one single sort of variable called an array. Containers is something like that, but better, as we will learn about them in a different video. The point is that when we will be using containers, as we'll learn, so number one, these containers internally will be doing stuff like allocating memory with new, deallocating memory with delete, and stuff like that. And these containers are pretty much built in such a way that they take care of themselves when they new and delete stuff. So we won't have to worry about deleting something that we allocated, etc. These container things will take care of themselves. Number two is that we will be arranging our variables and container objects in such a way that even though they are created locally and so they are submitted to the rules of scope, still we figure out ways to live with the rules of scope and still manage to do everything we want, as I will try to show in different videos. So what I'm trying to get at is, if you'd really like to save yourself some major headaches and different risks and violating Murphy's Law that if anything can go wrong it will, try really hard not to use new and delete as much as possible. Try to live with local variables and local objects, passing around pointers to them amongst different functions and stuff like that, as I will try to demonstrate as the videos go on. One last thing I want to mention so that I could just get over with this new and delete thing, which I hope to not speak about anymore, and that is that when you allocate arrays of variables on the heap, as you see how this is done right over here, we're not just making an integer, we're making an array of integers. Don't forget that when you delete that array, you must use a pair of square brackets right after the delete keyword, with nothing at all inside of those square brackets. Just don't forget to use those square brackets. This is a signal to the program that we're not just deleting one single variable, but we are actually deleting a whole array of variables.